So I would say, let's just get started. Hello, everyone. I would like to welcome you to the Clean Arctic Alliance's webinar, Scrubbers, the End of an End-of-Pipe Solution. Made up of 21 not-for-profit organizations, the Clean Arctic Alliance campaigns to persuade governments to take action to protect the Arctic, its wildlife, and its people. Before we start the program, first, a couple of housekeeping matters. Please note that the webinar will be recorded and made available after today. And secondly, if you have any questions, could you please try and indicate to which speaker the question is directed and submit it via the Q&A option, which should be near the bottom of your screen. We will endeavor to answer all questions during the Q&A session at the end of the webinar. But if time runs out on us, we will aim to follow up with a response after the event. So, in 2009, IMO decided to regulate SOx and NOx emissions from shipping. An important reason for this step was the impact of air pollution on people living near ports and in coastal areas. In order to reduce SOx emissions, IMO created two options. One, to reduce the sulfur content in fuel, or two, install and use exhaust gas cleaning systems or scrubbers. At the time, several parties, among others industry groups, were in favor of a worldwide shift to low sulfur fuel distillate fuels and against the provision of scrubbers. However, in the end, scrubbers were accepted as an acceptable alternative compliance mechanism, even when concerns about possible toxic discharge to the sea were raised. In recent years, several recent studies show that scrubber wastewater leads to cocktails of polluting substances, including heavy metals and PAHs, being discharged into the ocean. This justifies the call from several coastal and port states to regulate scrubber discharges in their coastal waters. Now, the Arctic is suffering from multiple stresses. Climate change is leading to loss of sea ice, with the Arctic warming 4 times faster than the planet as a whole. Polar waters are acidifying faster than other oceans, and also several types of pollution, in particular from shipping, are adding further pressure. The Clean Arctic Alliance firmly believes that scrubber wastewater discharge should be banned in Arctic waters. In this webinar, we will introduce 4 speakers, each with a different angle on the issue. After that, we will have a Q&A session, which will be curated by Sam Devin of WWF Canada. Now, we have 4 very interesting speakers, all very knowledgeable. And our first speaker is Anna Lunde Hermansson of Chalmers University of Technology in Gothenburg. And she will elaborate on risk and impact assessment of scrubber water discharge. So Anna Lunde, the floor is yours.
Thank you for this. I will share my screen. And I hope you can see it now in full screen mode. And I will also give you a pointer here. Okay. So hi, everyone. My name is Anna Lunde Hermansson, and thank you for the presentation, Elko. I'm a PhD student at Maritime Environmental Sciences here at Chalmers University of Technology in Gothenburg. And today I will talk to you about the risk and impact assessment of scrubber water discharge, something I've been working on for a majority of my PhD time. So I'm part of this large EU project called, or Horizon 2020 EU project called EMERGE, which stands for Evaluation, Control and Mitigation of the Environmental Impacts of Shipping Emissions. And we are a large consortium with 18 partners from 10 different European countries, coordinated by FMI in Finland by Jukka-Pekka Jälkenen. We have study sites in 5 different case study areas, and I've also participated in an onboard campaign. Within this project, we do atmospheric and marine distribution modeling of different contaminants related to scrubbers and shipping. We also attempt to do chemical characterization, both in water and air, and a large group are doing ecotoxicological tests in these different case study areas. And all of this is synthesized down into impact assessments and optimization modeling, which I will talk to you more about today. So this eMERGE project is coming to an end fairly soon, and this is resulting in a synthesis of 3 reports. And today I will talk to you about deliverable 6.1 that we just finalized, and it has been approved by the European Commission, and it's you can find it at the Chalmers Research Repository, or email me as well. So this report and the results that I will discuss today is focusing on the Baltic and the Baltic Sea and the North Sea. And you can see that here in the up here in the north. And then we also have these 2018 as our baseline year, and then we have done scenarios from 2050. And due to lack in time, we will focus on the 2018 data. What I want to say here is in 2018, we had less than 1,000 scrubbers globally. And if you look at the bars over here in 2022, 2023, we are reaching above 5,000. So what we will see in many of these results can be considered underestimations. So in 2022, the Marine Environment Protection Committee of the IMO approved these guidelines on how to do impact and risk assessments. And what we are trying to do is to follow the structure of this in order to do an impact assessment of scrubber water discharge. So in this document, it's stated that the adoption of restrictions or a ban of discharge water from EGCS, that is exhaust gas cleaning systems, which is scrubbers, should be considered in areas where any of the following indicative criteria are fulfilled. So the environmental objectives in the areas are not met, number 1, or number 2, the discharge of exhaust gas cleaning system effluents represent an additional risk. That is also a concept I will touch upon. And then we have also that the discharge water conflicts with other conventions, and also that it represents an increase in cost of management and dredge materials. So for this presentation, I will focus on the 2 topics, the 2 criteria here. So for the first one, it's more straightforward. In the European Union, we have this Marine Strategy Framework Directive that is assessing the environmental status of our waters. So we had a look at that. So here, mapped to the left, we have aggregated all descriptors. So the Marine Strategy Framework Directive consists of 11 different descriptors with a lot of indicators within them. And here we did the aggregated version where it's essentially one out, all out. So most of the European waters are red. That means that we are not fulfilling good environmental status. If we look at one specific descriptor, descriptor 8, that handles contaminants, which is very relevant when it comes to scrubber and discharge of scrubber water, we see that the North Sea area and the Baltic Sea area, all of the basins are red and essentially not fulfilling good environmental status. So following the MEPC guidelines, we see that ban on discharge of water from scrubbers should be considered in the Baltic Sea area and in the North Sea area. If we then move forward to point 2 of these impact assessments, where the discharge of exhaust gas cleaning effluents represent an additional risk of deteriorating the environment, this becomes a bit more tricky. Then we need to define how do we assess risk. And the guidelines, the MEPC guidelines provide some guidance on this. And we can use what is called a PNEC and a PEC value. And I will go into detail, a little bit more detail on this. But a PNEC value is the predicted no effect concentration. So this is the concentration that can be considered safe for organisms to be exposed to. And then we have a predicted environmental concentration. That is essentially the concentration that these organisms living in the environment will face. So a conventional environmental risk assessment builds up on these PEC and PNEC. So we have the chemical fate and distribution models that feeds into our area of interest, and we can derive a predicted environmental concentration. For the ecotoxicity, for the PNEC values, we use ecotoxicological tests. So we expose organisms to different concentrations of scrubber water or single substances. And then we can calculate a risk characterization ratio. So we compare our environmental concentration with the no effect concentration, and we see if this risk characterization ratio, so RCR, if it's above 1, then we have an unacceptable environmental risk. And if it's less than 1, it's said to be an acceptable environmental risk. Sounds easy enough, but if you can do this for single substances. So for example, vanadium that we find in scrubber water. The problem is that the scrubber water contains of at least 60 different compounds that we have identified. And it's very time consuming and computationally heavy work to do these chemical fate and distribution models for this. In addition, we are lacking predicted no effect values for a lot of these compounds. So it becomes a bit tricky. What we found within eMERGE is that we have, so usually we look at these metals and the US EPA 16 PAHs. Those are the usual suspects, so to say, and we have PNEC values for these compounds. But if we add, for example, alkylated PAHs that we have done in, we modeled these predicted no effect concentration, we see that these compounds can actually constitute up to 85% of the toxicity in the scrubber water. So we have a mismatch between available data and what is actually shown in these ecotoxicological tests. But the guidelines, so the MAPC guidelines leaves room for this. So they offer an opportunity to do environmental risk assessment using whole effluent testing. So this means that you expose the organism to these different dilutions of whole effluent testing, and then we can calculate PECs based on modeling efforts in dilution of scrubber water. So that's what we have done. So within eMERGE, these 5 different case studies have conducted scrubber water exposure in different concentrations to different organisms that you can see here, and different life stages of these organisms. It's also complemented with mesocos studies. And we see that from these tests that we see effects in the developmental stages at the lowest tested concentrations. So 0.001%. 0.001%. So we use these ecotoxicological test results to derive a general predicted no effect concentration for the scrubber water, open loop scrubber water, I should say. And we can also use these data to look at the lowest observed effect concentration. So that's the LOEC. And then we need to compare this to modeling efforts of dilution. And this is also easier said than done. But we have done a small case study version. So it's in Öresund. It's between, here we have Sweden and this is Denmark. So if we look at the zoomed in map here, we have Sweden here and Denmark here. And Öresund is an area that is exposed to a lot of ship activities and closeness to land, Nature 2000 areas and so on. So in this area, we have modeled the discharge of scrubber water, so actual scrubber water discharge based on AIS signals. So we use a ship traffic emission model called STEAM that is provided by FMI. So we can model the discharge of scrubber water, and then we get the data of the discharge of scrubber water, and then we can model where this water is moving. And in this model effort, we have assumed that the scrubber water is like a passive tracer and has a sinking velocity of 1 meter per day. And this simulation was done in July 2018. So from our ecotoxicological studies, we derived a PNEC general, so predicted no effect concentration of 2 times 10 up to -8. So this is the line here. So everything below that line is deemed as an acceptable risk. We also have our lowest observed effect concentration here. So that is the effect concentration that we get from the ecotoxicological tests at about 10 to -6. But what is quite striking in this image is that we see that we have a risk characterization ratio often about 100, sometimes or quite often about 1,000, and even of 10,000 more than would be deemed as an acceptable risk. So there's quite strong evidence here that based on the ecotoxicological test and this modeling effort, we are facing an unacceptable risk in the most of the Öresund area. And just to show you an example here, we have the map that I just show you up here so you can see the colors. And then I've just put the color bars next to these images. So this is based on an exposure experiments done here north of Gothenburg at IVL. And these are sea urchin larvae. So this is the controlled, and then you have different exposure of open loop scrubber water. And you can see that the larvae become deformed. So essentially these larvae will not become adult sea urchins. And a lot of these areas in the map are 0.001 or 0.01%. So to conclude, we see that the environmental objectives in the area are not met. We can also say that we find an additional risk of scrubber discharge water and possible deterioration of the environment. And I also want to finish off with that scrubber water is only one waste stream that we see from ships. So we need to include and have a more holistic view when we look at ships and ship emissions in general. So thank you so much for the opportunity to speak to you.
Thank you, Anna. It is clear that you could have told a lot more. Maybe you could have filled the whole program today, but so far this is very interesting information to get. And so as said again, this webinar will be recorded. So if you didn't get all the details of Anna's presentation, you can always look it back later. So now, having said that, we'd like to go over to the next speaker, Ludmila Osipova. She's with the International Council of Clean Transportation, ICCT, and she will speak about recent developments in scrubber regulations worldwide. So Ludmila, whenever you're ready, you can take the floor.
Thank you for introduction. I'm going to share my screen.
Perfect.
Is it in the full screen mode now?
Yes.
Okay, that's perfect. Okay, then hello everyone. So as Elke already said, my name is Ludmila. I'm a researcher at the International Council on Clean Transportation. And today I'm going to talk about our global update on scrubber bans and restrictions around the world. And just to give a little bit of the context, this study that I'm going to present on is kind of a continuation of the study we did 2 years ago in 2021 by looking at the global scrubber discharge water distribution. And this is the map, an excerpt from this study showing where the scrubber wash water discharges are happening in the world with some highlighted hotspots. We also estimated that the main contributors are container ships and bulk carriers, and the global discharge can go as high as 10 gigaton per year, and probably now higher, because as I can show you in this slide, the installation growth is continue increasing. Obviously, the most scrubbers were installed between 2019 and 2020 to comply with the sulphur cap, the global sulphur cap. But as you can see, the growth is not as drastic anymore, but it's still ongoing. And just between 2020 and 2023, it's 15% more installed scrubber in the world. And mostly these are open loop scrubbers with a small fraction of hybrids and closed loop scrubbers. And that's actually a trend that doesn't change with time. So the open loop scrubbers have been and continue to stay the most common scrubber type installed. So back in the days in 2021, we had a look which countries restricted or banned scrubber wash water. We found out there were strict restrictions, strict bans for 16 countries back then. But we only looked at the actual bans. So when the country deliberately write, like in regulations, that they're going to ban it. In this paper, we kind of look at the broader scope and also look at the bans and restrictions and what kind of bans out there. So see here, you can see a map of regulations and bans around the world. We find out there are 45 countries right now somehow ban or restrict scrubber wash water discharges. And mostly these are bans, meaning that it's not allowed at all to use it. And then 13 restrictions show there's some kind of partial restrictions of using scrubbers in the waters. As you can see from the map, like these points, they indicate ports, and the highlighted countries indicates the countries that implement the bans. And so even from the map, it's evident the ports, port level bans are the most common one. And the numbers says the same thing. The port area restrictions, almost 60% of bans, they are in ports, and then around 20% in territorial waters, and then the remainings are just sort of regulations or mix of regulation and restrictions between ports, territorial waters, or like special areas concerns. There are different ways how ports can regulate scrubber wash water. Here I just highlighted the most common ones and most interesting cases. Like the most common type of bans, it's just the ports or the national authorities published a circular letters regarding compliance with MARPOL Annex VI on the sulphur cap. So they just released the circulars explaining how exactly they want or do not want scrubbers in the national waters or in ports. The examples of these countries or areas as Suez Canal, Saudi Arabia did that, Pakistan, India, and many others did that as well. Another way of doing that is actually amending the port's information guide. That's what Vancouver Fraser Port Authority did in Canada. They amended the existing guide, and then that actually a very good example how the ban can be applied not just only to the open loop scrubbers, but also closed loop scrubbers in that case. And finally, there's some cases where use of existing national laws being implemented. And the example here is Germany. In Germany, they already had the existing CD&I convention that prohibit any discharges in inland waterways, canals, ports. And so what they did, they just agreed that wash water, that scrubber water is actually the same discharge like any others and also should be prohibited in this area. One thing that I would like to highlight that actually often switching to closed loop mode is considered to be a ban, meaning that if you use open loop scrubbers and you switch to the closed mode, if you have like hybrid scrubbers or like closed loop scrubbers, that's considered to be a compliance. And so we estimated that 64% of all measures, they're applied specifically only to open loop scrubbers. And only 29% of bans were applied to all wash waters, regardless of scrubber types. And that's actually shouldn't be the case, because there were studies showing that closed loop scrubbers are not emission-free. They also produce so-called the bleed-off water, which is basically the same wash water, but just more concentrated. And this wash water is supposed to be treated before being released in the sea. But there was a study done by BSH, it's a German maritime governmental agency, and they showed that actually the content of the bleed-off water is highly sensitive to what kind of treatment have been applied. And this is not regulated. So if you, let's say, apply to the closed loop scrubbers less effective treatment, it's still allowed to release it. Then also we just sort of try to summarize where in the world the bans are most common. And as you can see, the European Economic Zone and the UK is actually the area with the most bans and restrictions being implemented, followed by Africa and the Middle East, and then by the Americas. And while being already like upfront of the bans of wash water, actually there's a great news that only recently, this is a news from November 16th, so it's been only 5 days ago, that that the Transport and Tourism European Union Committee voted and adopted a draft of the proposal to extend this already existing maritime rules on safety and pollution prevention on discharges. And they sort of offered to include sewage, garbage, and residues from scrubbers as also as a pollution, as a discharge. And this is a great news. And if it's going to happen, that means that all European waters will not allow anymore to use scrubbers, both open loop and closed loop scrubbers. And something that I also wanted to add, that none of the regulations that we covered, like that exist currently, address specifically sensitive ecosystems or marine protected areas. Even though it could be actually the most urgent actions that are needed to do in terms of scrubbers regulations. Like here you can see a map of the coral reef distributions in the world. The green color shows global, like different coral reefs, and the red color shows the scrubber wash water discharges. As you can see, there's two hotspots, two areas where with the greatest richness of the coral reefs. It's in the Caribbean and also in Australia. And actually by coincidence, this is the least regulated areas and also with the highest discharges around the world. Specifically, we'll look at the Australia Global Barrier Reef marine protected area with some Australian scientists. And in that city, we estimated that around 32 million tons of wash water being released just in the Great Barrier Reef area per year. It's just annual release. And that was a big concern because actually that's not really something that is being discussed that widely right now. What is the potential damage that coral reefs can have from wash water, which is known to be acidic, and high acidity actually contributing greatly to coral reef bleaching and other processes that causing dying off of corals. And as a reaction, in collaboration with a few researchers from very well-known, recognized researchers working on Great Barrier Reefs, we actually wrote a chapter in the book that's going to publish in December on oceanographic processes of coral reefs. And in this book, we specifically contribute a section on wash water discharge in Great Barrier Reefs and all the potential impact it can have on the coral reef health. We were doing it by hoping that it's going to bring attention of the authorities, of the marine protected areas authorities, and also the government to this issue. And so just to wrap up everything what I just said, we made some sort of recommendations of potential actions that can be done regarding wash water regulations at the different levels. So at the IMO level, we think that we at least should start with stop discharging scrubber water in sensitive ecosystems and protected area, and like follow it with the full ban. Also, prohibition of scrubbers as an equivalent of sulphur compliance option would be also highly welcome. Then also at the national level and ports level, we can see that many examples when scrubber wash water have been banned, and that's what we also recommend to do to the others, including maybe joining the efforts between different neighboring countries, introducing water and sediment pollutants monitoring in ports, and also setting up on-land facilities for the area where closed-loop scrubbers are used, just to make sure that the sludge that closed-loop scrubbers produce being disposed properly. That's all from my side. Many thanks for your attention.
Thank you, Ludmila. That's very clear, and I think especially what's happening on the Great Barrier Reef, that shows that multiple stressors and cumulative impacts can cause great harm to such an area, and that may be the same case for the Arctic waters. So thank you for this. Our third speaker, it will be Navin Sundar. I hope I pronounced that in the right way.
Yeah, that's correct.
Good. He's a project engineer of Environment and Climate Change Canada, which is the ministry, who will present on marine vessel scrubbers, quantifying emissions to air and water in Canada. And I think it's quite early with you, isn't that?
Yeah,
is that right?
It's 8 in the morning here in Vancouver.
Oh, okay. Okay.
But no problem for us. We're all
Good.
early birds anyways. So
well, the floor is yours.
Perfect. Thank you so much. I just wanted to say thank you to the Clean Arctic Alliance for putting on this this kind of panel so that we can share all this information. And I'm just going to share my screen here. Please let me know when you can see the full screen.
Perfect.
Awesome. All right, great. Yeah, so just to reiterate, thank you all for joining in attendance. We're really excited to share some of the work that we've put together in terms of quantifying some of the emissions to air and water due to the increased use of scrubbers. So kind of the order, let's see here. All right, so I'll first go and set a little bit of a context as to why we started to do this work, and then go into some of our methods in terms of how we quantified some of the emissions, and then go a little bit deeper into some of the results and impacts. So actually, Ludmila had a great figure on the increased fitting of scrubbers in general globally. And we noticed the same trend in Canada, that over the years, we've been seeing more ships being fitted with scrubbers active in Canadian waters. We noticed that about 18% of large commercial vessels operating in Canada are already fitted with a scrubber. Cruise being 57%, containers being 30%, and tankers being 22%. So this being an impact to Canadian emissions and having, you know, air effects and water effects, we decided to add this as a component to our marine emissions inventory tool, which we'll tell you about in a little bit. But the first step essentially was to derive air and water discharge emission factors. Then we use those to essentially model the air and wash water pollutant discharges in Canadian waters. And then we looked at the potential impacts on aquatic species at risk. So ICCT had developed some wash water emission factors that you can see there in Table 9. And essentially you have different emission rates depending on whether you're using an open loop or a closed loop scrubber. And Table 5 right below that, it shows the relative emission changes after so compared to using HFO with the scrubber. So example being what's highlighted in red there, just one thing we kind of wanted to emphasize was the increase in black carbon. So what this is describing essentially is that if you switched from HFO with a scrubber, or sorry, if you switched from 0.1% sulfur to HFO with a scrubber, you would have an increase of 350% black carbon for slow speed diesel engines. So once we establish these emission rates, we're able to put them into our marine emissions inventory tool. And essentially this is a tool that uses AIS data to track the ship movements in Canada. So we have the position of the vessels, the time, the speed, origins and destinations. And the original intention of this tool was to calculate GHGs and air pollutants using emission factors from the 4th IMO GHG study. But since we have this added component of, we know which ships are fitted with scrubbers from our subscription service to Clarkson, as well as all this activity data, we decided to put those together and essentially develop an emission estimate, and we take into account all relevant regulations that are in play in Canada at the time. So I'll talk a little bit about what results we noticed after doing this analysis. And first, what you see here are the number of ships fitted with scrubbers by ship class. And we're comparing 2019 to 2022 here. What we notice is that the amount of cruise ships, it roughly stayed around the same. So the proportion went lower, but in general, all the numbers of other ships went up. So example being bulkers went from 91 to 394 ships. Merchant other from 15 to 71, containers from 16 to 170. So it is increasing just all across the board. In terms of proportions by ship class, we looked at this analysis just to see where the trends are kind of happening more. And kind of what I just spoke to a little bit was that you have a large increase in things like bulkers, containers, and tankers, and in general for the whole country, the proportion of total ships fitted with scrubbers in those 3 years went up from 5% to 18% in Canada. So the ICCT emission rates that I just went over in that table allowed us to see what the air emission effects are from ships that are fitted with scrubbers versus without scrubbers. So what you see here in blue is what the emissions would be if there were no scrubber activity. So kind of the non-scrubber scenario. And the orange portion here, you see how much scrubbers increased emissions per pollutant. So we have CO2 equivalents on the left here increased by 1%, PM 2.5 that increased by 7%, and black carbon that increased by 13%. Now, if we go to 2022, these numbers all increased. So I'll go back and forth here. So the notable differences are with PM and black carbon. So PM moved from 7 to 12%, and black carbon from 13 to 19% in terms of increase. And you can see the amounts in the table below there. So those are the air quality effects. Now moving on to some of the water quality impacts. First, we're going to look at the scrubber discharges. So this is all scrubber discharges that are within Canada's economic exclusion zone. And on the left here, you see 2019's emissions, and on the right, you see 2022's emissions. The most notable metric that we noticed was that the amount of wash water released nearly doubled between those 3 years for all of Canada. So on this figure, you see the tons of wash water released in Canada by year, but you can see how it increases or changes depending on the type of scrubber or the region. So in the east, we have both freshwater and seawater areas. So that informed our assumption of whether they're using closed loop scrubbers or open loop scrubbers in those areas. And in the Pacific and the Arctic, they would have been nearly all open loop scrubbers. And the biggest increase here we saw was from 2021 to 2022 in the Pacific. So we will move on and look at a pie chart of this, kind of looking at the total wash water discharges by ship class. And in 2019, you see that it was dominated by the cruise ships. And as we started seeing more and more other ship types fitted with scrubbers, that cruise portion of the pie went down, and we see more wash water emissions happening from containers, bulkers, and tankers as well. Okay. So after coming up with an emission estimate for all of Canada, we wanted to look at specific areas that might be of focus. And two of those areas were the areas for the St. Lawrence Estuary beluga and the southern resident killer whale. So the St. Lawrence Estuary beluga, it's as in the name, typically is around the St. Lawrence and the Gulf, and the southern resident killer whale is on the west coast in the Pacific region. So first here you see in our marine emissions inventory tool, kind of the boundary that we considered for the beluga. So that's just the St. Lawrence River crossing with the Saguenay River there. And we found that the number of ships fitted with scrubbers increased by quite a bit, more than double between those 3 years. And the emissions all increased by nearly double as well. So you can just see the values here. So in belugas, the high PAH concentrations correspond with higher rates of digestive tract cancers and tumor production. So this is just to note that an increase in these amounts can have the possibility to have some effects. And I know, Anna Lunda, you've done some work on some dispersion modeling to actually find out how, you know, some of these things have effects. So that could be something where our emission output could provide an input for the dispersion modeling, perhaps. So for the killer whales, this is the region around Vancouver Island that we looked at. And again, you can see the emissions here in this table, and everything increased again by quite a bit in those 3 years, almost by 3 times. So for the killer whales, the PAHs, copper, cadmium, and lead are priority contaminants for the SRKW primary prey, the Chinook salmon, and it's based on presence, health concerns, and likelihood of exposure. So mercury is the priority contaminant for both SRKW and Chinook in this area. So we have a few key takeaways here. So we've noticed that the number of ships fitted with scrubbers has been dramatically increasing in Canada, and it has negative confounding effects on air and water quality from having a scrubber on board. And ships using scrubbers in endangered marine mammal critical habitats are discharging millions of tons of wash water containing substances identified as threats to whales and or their prey. So there are downstream effects from the use of scrubbers that may cause us to look more at the problem and maybe make some decisions down the line. So yeah, thank you all so much for listening, and yeah, thanks.
Thank you very much, Navin, for this, for your presentation. And yeah, it's sort of, I think it's sad to hear about the direct impact, or so seemingly direct impact, on endangered species like orcas and belugas. That is something, yeah, that we really should try to overcome. And especially since these animals are also under threat from different stresses, like in the orcas in the Pacific Canadian waters, also suffer from underwater noise and other stresses, etc. So yeah, well, it's good to have this information, and this may lead to, to action.
Absolutely.
Okay, thanks. So
thank you very much.
Last but not least, we have Rosa Antidormi in our midst. She's a policy officer, Maritime Transport Sustainability at the European Commission, DG Environment, the Marine Strategy and Clean Water Services. And Rosa has been around the IMO processes for quite some time, I believe, and she will speak about issues with alternative compliance options in emission control areas and with the global sulphur cap. Rosa, the floor is yours.
Good afternoon to all, and thank you very much to Clean Arctic Alliance for organizing this very timely and very important event. And thanks also to the previous speakers, which really set the scene fantastically with data and the science behind the concerns we have. I will start my presentation now. I hope you see it. Okay, no, that's not.
Yes.
That's not
full screen.
what I wanted. Okay, maybe this one is better as a start.
Perfect.
Indeed, thank you so much. Indeed, I work for the Environment Department of the European Commission, and I deal with the sustainability of maritime transport. I work with colleagues in IMO, with member states, and with the Transport Department of the European Commission. Allow me to give you a very brief overview with some flashes on the EU context and what is happening also these days in the Commission. Well, the Environment Department has adopted the Zero Pollution Action Plan in 2021, and this is our feuille de route with several actions and several goals and targets we have to achieve reduction of pollution in air, water, and soil. This has led to 20 plus Commission proposal of new legislations. Very recent these days, you may have read about the adoption of the Nature Restoration Law, which asks EU member states to develop plan to restore the environment which has been damaged. So quite close links with our topic today. And also an agreement was reached on the Environmental Crime Directive, which gives importance and gives the responsibility to the polluters for their acts based on the polluter pays principle. Ongoing, of course, are also legislation on urban wastewaters and water pollutants. There was a revision of the water standards pollutants lately, and on the implementation side, water use and drinking waters, and notably development of secondary legislation on microplastic. Now, what is coming up in 2024, end of mandate of the Commission and so on. Indeed, the evaluation of the Marine Strategy Framework Directive will be adopted next year in view of an ambitious review of this directive. We heard Ludmila and other and Anne speaking about the work, the efforts the member states must put in practice through measures in order to achieve good environmental status. And we saw for contaminants, we're not yet there. A new initiative will also be launched about water resilience. This looks more into the sustainable use of water resources, balanced water management, secure the water, and it aims to secure strategic self-sufficiency and preparedness against ecological and geopolitical crisis. Water is at the center. There is a source to sea aspect there, covering parts of the sea from the perspective of a possibility to desalinization and provide water access and increase the contribution to water access to coastal states. Also, allow me to flag very briefly the review ongoing on the Ambient Air Quality Directive, which of course relates to air pollution, aligns with the latest guidelines from the World Health Organization. It will apply in ports. It will have a special attention on ports with increased monitoring on ports emission. And also in general, we know that atmospheric deposition of air pollutants is cause of acidification and eutrophication, which is an important contributions to the water quality. In the context of the Zero Pollution Action Plan of activity, as data are important, and I'm grateful for the previous speaker for providing those in a very eloquent and rigorous way, the Joint Research Center of the European Commission and the European Environment Agency are compiling, in view of publishing at the end of 2024, the second Zero Pollution Monitor and Outlook report, where there are data for air, water, and soil, modeling activities, trends, and identification of gaps for future work. Very quickly, also, our sustainable and smart mobility strategy we have adopted in the Commission in 2020 focus on climate change, amongst others. We have a goal, zero emission large-scale ocean-going vessel market ready by 2035, ambitious goal. That's with the aim to achieve total climate neutrality by 2050. We have adopted a package of legislation under the name Fit for 55. I apologize for all the perhaps acronyms, but happy to clarify if there will be time. Indeed, the adoption of the FuelEU Maritime is a cornerstone with decarbonization and energy fuel transition. It will also reduce shipping emissions and noise, but not a no harm level. We have complementing legislation, regulation, and initiative accompanying the FuelEU, and these are the alternative fuel infrastructure, the energy efficiency, the extension of ETS to the maritime sectors, and other market-based instruments. We have, of course, in the strategy also the upcoming work on new emission control areas in new waters. We just had adopted the one on the Mediterranean, next in line in this Northeast Atlantic, and from the IMO, good to see that our colleagues in Canada are also looking into the feasibility of an ECA extended to the Arctic water. And then also looking into water impacts, ongoing is the review of a ship source pollution directive. It's a piece of legislation that looks into illegal discharges from ships in general. The review aims at including more annexes of MARPOL, so to increase the alignment with IMO legislation into the EU. It aims at strengthen enforcement, collaboration among member states, better alerts of pollution incidents, and also penalties, more effective penalties when an illegal discharge is evidenced and caught. Linked to the topic today, in 2024, we're working on revising the European Maritime Transport Environmental Report. There was a previous version published in 2021, and there are some indication that you had better, fresher data today. Indeed, in Europe, the largest ship water discharges, the larger fraction comes from exhaust gas cleaning systems, open loops at a percentage of 77%. It's an interesting data, but okay, you have fresher data today. Let's go now to the topic. What are the EU concerns regarding the discharges to water from ships equipped with scrubbers? Well, we have heard, we have really clear cut, very comprehensive scientific and technical evidence of the impacts of these discharge waters into the sea. They are negative, they entail toxicity, and they have negative impacts on the marine environment. All these studies, okay, some have been presented today, but of course there were many others by other research organizations, and I want to name them because I'm really important studies from Belgium, Sweden, Germany, Greece, Netherlands, Finland, basically the emerge our colleague already introduced before. Many of these studies have also are also funded by the EU. So we are proud to see such results coming out from our funding. We have also reports from the European Commission, the EEA and EMSA, where we also assess data reported under EU legislation by the member states, and not only under the Marine Strategy Framework Directive, but also from the Water Framework Directive. We had, of course, during the IMO process in the past year, GESAMP also coming up with interesting report, which has been shared with IMO states. And at the regional level, we have this year published in the European Regional Sea Convention's quality status reports, which also represent regional efforts. Some of them are also shared with the IMO. And are really also an asset and give an important contribution to the global discussion. Our concerns are long dated. Yeah, we heard at the beginning, Helco said that scrubbers have been allowed after the landmark revision in 2008 of Annex VI. That was true, but that was also allowed under strict condition of evaluation of impact, and these were considered at the time best available technology. Indeed, all these studies and the polluter pays and precautionary principle, and as well as the higher global awareness about the impacts we are discussing today, including from the IMO work, led many countries banning scrubbers, mostly imports with different, let's say, a scope of application and so on. But this is very encouraging, but at the same time, it's also worrying because what we try to do at the IMO, it's really to avoid patchwork of regional regulation, and the aim would be to have uniform and unambiguous rules that apply. Other concerns regarding scrubbers, installation of scrubber choices as a compliance option. Indeed, in 2015 or before 2015, the premium between high sulfur and low sulfur fuel cost was really prohibitive. If my memory serves me well, we were talking about $800 per ton difference, which was really a huge cost. This gap has decreased in 2020, but indeed with the COVID and the global regulation, indeed has seen another wave of scrubber uptakes. Allow me, I put 5% globally, but I put it in square bracket. Happy to be corrected if this is still a representative number in the global scale. I read today we are around 4,300 ships, and if we consider 20,000 ships trading worldwide, that could be a figure, but happy to be corrected. So the question today is it really there an economic case for installing scrubbers? And is this covering health, environment, and society costs at large? You know, we are of the order of 1 year return of investment for operators opting to invest in this technology. So the question is there. Is there coherence with greenhouse gas development? It's very important that we reason in a holistic manner, and very important looking in trade-off, absolutely. And if there are increases of CO2, decreases, black carbon, very important, especially in the Arctic. So really, we must have to the widest possible extent a holistic approach, a fully life cycle approach. But indeed, we know that at the same time, ships equipped with scrubbers could go at higher speeds because the fuel costs less. And I mean, in the general picture of decarbonization, does it make sense to still allow high sulfur, so the dirty type of fossil fuels still in the market? Is this delaying their phase out or not? We also have a number of enforcement issues that are worrying us. And these come from, for example, from measurements from remote sensing, which detect several non-compliance in new waters coming from ships equipped with scrubbers. So what's wrong there? Is the scrubber not working? Is the scrubber on or not? There is also an issue of inspectors' knowledge and training. Not everywhere there is full capacity to assess compliance on ships where the systems are installed. And also another warning is the malfunctioning of these systems, which is covered even by a EGCS at the IMO, and which allow in strict condition the use of high sulfur fuel. Also there, it's a bit worrying if there are enforcement issues and also malfunctioning issues. One starts, if you put all the elements together, this maybe plays in disfavor of opting for these technologies. Now, I don't have the crystal ball, as you don't, but okay, I'm trying to imagine and anticipate with you. Okay, it's not rocket science, but there are elements that we will certainly need to consider or reconsider at PPR 11 next year, and these are more general, such as do we have sufficient maturity, political maturity of the IMO process to make, to make a clear step in terms of regulation? Is there clear-cut science? From what I heard this morning, and for all the science has been developed so far, I would say yes, but is that shared in the IMO? Do we all share at the IMO the need for mandatory requirements? And what this regulation is, it will look like if it will ever be agreed. We will need to be compatible with existing guidelines in terms of content and language. How can we move? How can the two coexist, and why do we need a regulation in MARPOL otherwise? There are elements, of course, linked to the geographical scope of application. What are going to be the seawaters where this potential regulation will apply? Territorial waters, beyond territorial waters, port areas, only in MPAs or in ecologically sensitive areas, to be seen. There is an ongoing also question to the IMO, to which we will hear a reply, a legal question on potential legal conflicts between UNCLOS Convention and MARPOL. A reference to Article 56 is made, but of course, if we dig into UNCLOS, we have also a wealth of other articles of the convention that tell states and organizations not to transfer pollution from one environmental compartment to the another one, like in Article 159 and so on. So indeed, what will be maybe the showstopper or the elements which we will have to work at the IMO? Yeah, how there is a potentially restrictive application. What will be the precondition for adoption by states? How conditional we will make the regulation, if any, if ever adopted, on other elements, for example, agreement by other littoral states and so on. What will be the reference document? There are many valuable documents on the table from Japan, CISA, and others, Canada and others. What could constitute the elements of a potential compromise across the different views? And would that be possible by considering an appropriate timeline or a staged approach? how much are we prepared to consider investment made? Because these are not the investment made in 2015, are the investment made in 2020, any grandfathering. So really food for thoughts and ample possibilities to eventually find a compromise. Of course, the EU position, the official EU position is set out in EU documents. The last one was MEPC 80/5/5. I cannot anticipate anything for PPR 11 because simply we have not yet prepared and finalized our position for PPR 11. This will happen at the beginning of the new year, so I cannot say anything about that. Just to close on other ship discharge, we heard the colleagues from Canada looking into impacts on species. And yeah, I'm happy to recall as other topics where I've been working hard, of course, the emission control areas in the Mediterranean, which, okay, will have to happen. It's timely to have now this discussion on scrubbers, so it will have to happen possibly in the most sustainable manner. There were also other areas such as the PSSA established in the northwest of the Mediterranean to reduce ship collisions with cetacean. And the anticipation there, the envisaging there, the possibility of using operational measures like blue speeds, so-called low speeds. Very important piece of work that our colleagues in Canada have excellently coordinated. And this is the revision of the guidelines on the reduction of underwater noise with the work plan ahead, entailing many elements: dissemination, incentivization, research, and possibly also start considering measures to address underwater noise. And always very important to keep well in mind the linkages with development on greenhouse gas and energy efficiency there, trade-offs, important to reduce fuel consumption. And this has also benefits on pollutants, biofouling, underwater noise. So more and more, we encourage to have a holistic approach on pollution issues. Some conclusions.
Oh,
yeah.
No,
I just
going to interrupt you because.
Yeah. Okay. No. That's it's finished. These are not conclusive conclusions because you see very much work in progress. And indeed, bottom line for us is that the European Commission is the last bullet. The European Commission and the EU favors to work with IMO states before considering any action at the EU level. So that's clear. We would like to have a recognition of the issue in a regulation at the IMO. That would be our favorite way forward. Thank you, and sorry for overtime.
No problem, Rosa. This was very, very useful information and a lot of information. And so we can always, I saw there was a question about the slides, and everybody can always see the slides back once it's on our website, and so there's no problem here. We come to the Q&A session, and I'd like to introduce Sam Davin. Sam, can you
Thank you, Elko, and to each of our speakers today, thank you very much. We have a few questions in the chat. So our first question is for Naveen. Could you kindly explain more slowly and clearly what your slides on incremental emissions show? Thank you.
Sure. Yep. Let me just share my screen here. All right. All right. Can you all see it fine?
Yes.
Yes.
Okay, perfect. So, what you see here is marine emissions in 2019 for CO2, PM 2.5, and black carbon. This is for all of Canada. And so what you see in blue here are what the emissions would be for all of Canada in the case that there were no scrubbers. So they were using a cleaner fuel, which is an ECA, emission control area compliant fuel, to reach the sulfur standard. What you see in orange is if it's kind of the as is real world scenario where if these ships that are fitted with scrubbers are actually active, here's the incremental emissions that you see as a result. So you have a no scrubber scenario, and then how much extra emissions are being caused due to scrubbers for CO2, for PM2.5, and for black carbon. So what I wanted to demonstrate here was just the difference in 2019 and 2022 for those two cases, just to see how much the air quality impacts are increasing between those 3 years. So this is 2019 here. And when we switch to 2022, we see that, let's switch it here. The PM increases from 7% to an additional 12%. The black carbon increases from roughly 13% to around 19%. And CO2 stays roughly the same percentage-wise, but you can see the values here in terms of tons of pollutant in each case. So in 2018 or 19, for example, we had 8.7 million tons of CO2 equivalents, but in 2022, we had 9.5 million tons of CO2 equivalents. And yeah, so that's kind of what we were trying to demonstrate here is the air emission distribution changes between the 2 years.
Thank you very much for walking us through that. To the individual who asked that question, if you have any follow-ups, please feel free to put those in the chat. Our next question is for Anna, and I'm synthesizing this question. So given that the North Sea and Baltic areas are not in good environmental status, can you speak to any existing noted adverse ecological impacts that have already been observed? And if possible, any published resources that you could point to would also be welcome.
Sorry, I didn't get the last part, but I can answer the first. What did you say in the last part?
Oh, the second part was simply if you can point to any specific studies that would also be welcome.
Okay. Yeah, so in terms of like environmental status of Baltic Sea and the North Sea, that has been monitored over time. And there are reports on that connected to the Marine Strategy Framework Directive and so on. But connected to the implementation of scrubbers, I don't know if there are any direct studies connected to that. There's always this tricky thing when you go out into the real world and the real environment, as I showed with the last slide, that you have, yes, we have scrubber water discharge. We show with the ecotoxicological studies, we show that very low concentrations of scrubber water has an adverse effect on species, certain species and life stages. But then, of course, we have a lot of other things that can affect that. So connecting that connect the direct effects from one waste stream or emission source into an effect of a whole ecosystem is very complicated. The Baltic Sea is, as most of you know, sea under high pressure or many different types of pressure. So yeah, I cannot on the top of my head come up with any publications now, but I can think of it and add it to the reference list on my slides. And then also connected to ship emissions. It would be great to do monitoring in areas like in ship lanes, for example. But it's really tricky to go out and sample in ship lanes because they are trafficked with very large ships. So I think that is also an issue that we can meet out in the field, so to speak. I don't know if that answered all of the questions, but yeah, please add follow-ups.
Thank you for that. And if there are any follow-ups to Anna's question, please feel free to put them into the chat. Our next question is for Navin. What would be the mechanism for additional black carbon when you add a scrubber to the ship? Increased fuel consumption, sure, but the scrubber washes out some particulate matter from the exhaust. So could you expand on where the extra black carbon is coming from?
Sorry, I was muted there. So I don't know in terms of like the technical specs of the scrubber, like how that black carbon is actually, increasing or not being captured in the process. So I would recommend there would be an explanation in ICCT's report for wash water emission factors, which is what we use. So I can point you to that paper, and then there would be an explanation in there, but I just don't have it offhand.
Okay, thank you.
Yeah.
Our next question is for Anna. And so I believe this question is just seeking clarification. This question goes, so with scrubbers, the air gets less polluted. However, that pollution goes into rivers, oceans, and seas. And so, Anna, I would feel comfortable saying that, yes, this is very much the case. But if you would like to expand on that, the floor is yours.
Yes, so what we see in the previous paper that we did, where we did essentially a literature review of all the data that exists on emission factors of metals and polycyclic aromatic hydrocarbons, comparing, so not focusing on the SOx, because that is effectively removed by a scrubber, so reducing the SOx emissions to air. But we do see that HFO contains more heavy metals and PAHs compared to distillate fuels. So even when using a scrubber but burning HFO, you can actually have increased emissions also to air of metals and PAHs. So I would emphasize the answer. Yes, you are moving the discharge to water, but you're not necessarily reducing it as well as you thought to the air either.
Thank you, Anna. And I wonder, Rosa, if you'd also like to comment on this question?
Well, if I may just share an observation, because, okay, indeed, we know that to reduce PMs and black carbon, we can use particle filters on board, and many scrubbers have, many ships equipped with scrubber have those on board. So there are other ways to cope with potential increases of black carbon, if any. And I would like also to invite to think wider, because we have now also EGCS for NOx. And actually the compatibility between scrubbers and SCR, for example, SCR don't work very well with high sulfur fuel. So, trade-offs, it's a very interesting thing. We cannot simply conclude that scrubbers reduce air pollution. That would be a little bit too much, a conclusion that is not 100% corresponding to reality. That's, a warning on looking at the wider picture, and also at what systems are really used on board to increase or decrease certain air pollutant or water pollutant. Thank you.
Thank you, Rosa, and thank you, Anna. Reviewing our questions, I have a question that I would like to pose that's been inspired by some of the comments that we've received. So today, to varying degrees, each of you spoke to impacts on the environment and marine species. To give a few examples, Anna, you pointed to adverse impacts on the developmental stages of some wildlife, including sea urchins. And Ludmila, you identified the relative dearth of regulations in relation to designated protected areas, and specifically to overlaps between discharges and coral reefs. And Navin, in addition to touching on concerns related to stack emissions equivalency, you also mentioned that scrubbers discharge contaminants into areas inhabited by species like St. Lawrence beluga and the southern resident killer whale. And Rosa, of course, one of the many topics you touched on included the question of jurisdiction and waters, both within and beyond territorial seas. So my question for any of the panelists who would like to tackle this is that given that many protected area boundaries extend beyond the territorial seas of individual states, so beyond that 12 nautical mile mark, and due to the fact that marine wildlife are oftentimes mobile, as well as the fact that scrubber discharges disperse after being emitted, how would you rank the relative importance of local, national, regional, and international mitigation measures on this issue? Anna, please.
Yes, I think you touched upon some very important aspects of this. We know that marine protected areas can have a really strong protective, yeah, it can be very protective, but it can also, we don't see any boundaries in the ocean, so things can flow through this area and affect it, even though we try to protect it. I also want to add to this that the shipping industry is also mobile. So by putting up bans or restriction in certain areas can move the fleet that would no longer be allowed in a certain area into another area. So I think that is also an important aspect to consider when considering the scope of a ban or a restriction, that in terms of being fair and also securing and protecting more areas, it should be made as large as possible, I would say. Yeah, thank you.
Thank you, Taylor. Naveen, would you like to comment on this as well?
Yeah, I think that's a good point, just in general, just because you have these moving sources. So the last thing you would want is for, say, a scrubber ban to be in action, but then if it's only in certain areas, you end up having avoidant behaviors of these ships. So, you know, you probably could find this with something like an ECA. If there's an emission control area implemented, perhaps there's activities to avoid that area, right? And then which case is that intended purpose actually following through and being committed to? So it's probably a good idea to, you know, grab as large of a scope boundary wise as you can for the relevant areas. And that's something I guess you have to optimize and take another kind of technical look at, to look at what's the maximum optimal area where you can make this adjustment effective. So yeah, just wanted to add that.
Ludmila, please.
Well, I think it's a really great question, since all the regulations are usually sort of cover coastal area. They're not even cover territorial waters. Most regulations just bans on port level. And this is really important because when ship travels between two different ports, especially on long distance, like it's allowed to use scrubbers, even if it's banned in certain ports. And the ship actually can switch between scrubber and using other alternative fuels. So I think what would be interesting to see is it possible to prohibit using scrubbers in the marine protected area that's going to be designated 30 by 30 by the UN, right? We're going to have 30% of our oceans seawater protected by 2030. That's already decided. It's just a question, where are this going to be happening? And that would be a really good initiative if someone would raise the question, like, would scrubber wash water be included and like be excluded from this area, right? So then in this case, you know, at some point, if port ban discharge, if this area that the ship have to cross port also ban discharge, it's at some point for the ships, it's going to be it would not make sense for them to install scrubbers and invest money into them, because it's going to be too many patches where they can't enter with scrubbers. That's my perspective on that.
Thank you to everyone for your answer on that. I do want to come back to a comment we've had from the audience regarding our former discussion on particulate matter and black carbon increases. So this comment reads, regarding particulate matter and black carbon increases, exhaust gas cleaning systems are a mitigation measure for sulfur oxides, not particulate matter. Heavy fuel oil produces greater particulate matter than the equivalent distillate fuel to meet the sulfur oxide requirements, which explains the increase in particulate matter and black carbon when using exhaust gas cleaning systems instead of a compliant fuel. Okay, so thank you for that comment from the audience. Moving on to the next question. Ludmila, this is for you specifically. You presented that the European Union is considering to add sewage, garbage, and scrubber wash water discharges to their pollution regulations. Do you know when clarity is expected related to this?
Thank you for asking this question. We actually do not know. We don't have that much information. I don't know, maybe Rosa knows more than me. That just was announced on the 16th. So we don't know yet. Probably it's going to be some legal procedure for approving through the entire process to make it happen. So, you know, that's a proposal, approved proposal. So it doesn't mean that it's going to happen.
And Rosa, did you want to come into that as well?
Yeah, just a little clarification. Normally, in the EU institutions, it is the European Commission that is the legislative body of the Union. So it is up to us, let's say, to make a proposal for new legislation. I think that discussion happen in the European Parliament, which is part, of course, of the legislative process of the Union, but it's just one, let's say, one actor together with the Council of the Member States. So the draft resolution, that was adopted, that indeed that shows that citizens have under their close radar screen the need of a ban. But how this is going to be then reflected into EU legislation, it's a different step, it's a different process. At the moment, what is happening, I briefly referred to that. There is a review of the directive on ship source pollution, which is going to make, it's not going to ban scrubbers, that's not the case, but it's going to make penalties for illegal discharges of residues and discharged waters much stricter. So that's the only development I could think of, because otherwise the other legislation we are looking at are more like, for example, the review of the marine strategies or other legislation that fix, let's say, the objectives, the targets to be reached by the member states, but they do not specify the means to achieve the targets. So they leave the discretionality to member states to put in place measures to achieve those targets. Then this is something that necessarily does not look specifically into scrubbers or into any other polluting sources, because for the sea, for example, we have the offshore industry, we have the fishery also causing pollution. So we have many, sea-related pollution sources. So I can't confirm this is really being enacted into a fully fledged legislation.
Thank you, Rosa. I note that we've reached the top of the hour. I realize there are some lingering questions, but Elko, I'm going to pass it over to you at this moment.
Oh, thank you for that, Sam. That was exactly, we're on the hour, but I thought the last question I see on the screen was also too interesting to just, I think we should tackle that briefly or raise it briefly. And the question is, would you see a global EGCS restriction a realistic goal, or are we looking more likely a regional scrubber ECA? Who would be in the position to answer that? Maybe Rosa?
I guess nobody's in the position to answer that. But okay, as we say in the IMO, of course, I gave you a sense, a picture of where we stand. We know that when we try to move forward and we are very many on board, I mean, we go slower, but I mean, we really move all together, and that's an added value. At the moment, I'm not sure. Certainly, there are delegations that are very firm and determined to move on, others that are more mitigated. So, yeah, it will have to be seen if this will be just, again, yet another ECA for scrubbers, or it will be a global. Probably, considering that we sense some difficulties and perhaps there is not yet fully political maturity on really take a radical stand of a global ban, which for some would be the logical way forward. Yeah, it would be good to consider potential regional or staged approach. And let me go quickly to the question on the relative value of regional, local, and national and global legislation. I would like to point out that the IMO, also in other endeavors, like, for example, the plastic strategy, is very much informing and very much in working in synergy also with the Convention on Biological Diversity, because it's really important that these two worlds merge and they try to have some interfaces to enhance, you know, find the achievement of the goals. For the moment, it is true, as I said, we have, let's say, legislative realms that are more objective oriented and not the means. So these two, I see them getting closer and closer on various topics. And plastic is the first that comes to my mind, but there are many underwater noise as well. Because indeed, yeah, the international international regulation are indeed super important, especially for shipping.
Well, thank you. If there's anyone else who has a quick answer to that question, then please shoot. If not, I would say that, well, the scrubbers are connected to heavy fuel oil, and since we have to decarbonize the maritime industry anyway, so in the end, scrubbers will go out, but that may take a long time. In the meantime, as we come to the end of the webinar, I would like to thank all our speakers and thank the audience as well for joining us and for your questions. So this webinar is being recorded and will be available soon on our website, where you will also find more information on our work. So I can highly recommend you to have a look at cleanarctic.org. And as I said at the beginning, the Arctic is already under immense pressure due to the climate crisis, and the Clean Arctic Alliance believes that scrubber wastewater discharges should be banned in the Arctic waters. So we will continue to campaign to ban the use of scrubbers in the Arctic, including at the IMO during PPR 11, which will take place in February next year. So thank you. And lastly, a final thank you to all the speakers for their input in the webinar. And look forward to seeing you at another event of the Clean Arctic Alliance.
Thank you very much, and goodbye to all. Thank you so much.
Thank you all.
Yeah.
Thank you to all our speakers again. Do appreciate you all joining.